Welcome to lesson 12 of Fundamentals of Chemistry. In this lesson, we are going to look at balancing chemical equations, and we are going to calculate moles from the given balanced chemical equations. So, the steps to balance the chemical or combustion equations, as we have already learned, combustion reaction. It is a reaction in which a substance reacts with oxygen and forms oxide with the release of heat energy. And in order to balance combustion equations of hydrocarbons, we have three steps. In the first step, we balance carbon. In the second step, we balance hydrogen. In the third step, we balance oxygen. Let's look at the example. We have C2H6, which is called ethane. When it reacts with oxygen, it produces carbon dioxide and water. Always remember, students, whenever you have a hydrocarbon, which is a carbon which is bonded with hydrogen, a compound formed by carbon and hydrogen, they are called hydrocarbons. Whenever you have combustion of hydrocarbons, that is, whenever any hydrocarbons reacts with oxygen, it produces carbon dioxide and water. So this is the same product for all. That means whenever you have a hydrocarbon, whenever you see a hydrocarbon reacting with oxygen, it always forms carbon dioxide and water. In order to balance this equation, we are going to apply these steps. So let's look at the reactant side and product side. So we are going to compare carbons first because we have to balance carbons. So we have two carbons on the reactant side and we have one carbon on the product side. As you can see, there are two carbons and there is only one carbon over here. So in order to balance this carbon, we are going to put two over here. Okay, so carbons are now balanced. Let's balance hydrogen. On the reactant side, we have 6 hydrogens. As you can see over here, there are 6 hydrogens. On this side, we have 2 hydrogens. So in order to balance this, the hydrogens on this side, we are going to multiply 2 with 3. So we are going to put 3 so that we get 6 hydrogens on this side as well. So we have 6 hydrogens and we have 6 hydrogens. Okay. In the last step, we are going to balance oxygen. Let's see how many oxygens are there. We have 2 oxygens on the reactant side. And in order to balance on the product side, we have 7 oxygens. How many oxygens? 2:2, 4 and 3. There are 7 oxygens in total. Okay, so in order to balance this odd number, for any odd number, whenever you get an odd number, we can use fraction. Okay, and fraction is going to be 7.5 in this case. When we put 7.5, that is equal to 3.5. When you multiply 3.5 with 2, you're going to get 7 oxygens over here as well. Okay, or simply 2 and 2 will cancel out and you will get 7 oxygens. So oxygens can be balanced with fractions over here. So in combustion equations, always remember, students, you can use fractions to balance the chemical equations. Now in order to simplify further this equation, if you don't want to have fraction or you want to simplify this fraction, we are simply going to multiply the whole equation, this whole equation that we have got, with 2. So once we multiply the equation with 2, we are going to get 2C2H6 because there was only one. So now when you multiply it with 2, you get 2C2H6. This 7.5 multiplied by 2 is equal to 7. This 2 multiplied by 2 will be equal to 4. And this 3 multiplied by 2 will be 6. Okay, so this step is not mandatory, but if you know it, it's good. Let's look at another example. We have C4H10 reacting with oxygen. C4H10 is called butane. When butane reacts with oxygen, it produces the same product. What is going to be the product in this case? We have carbon dioxide and water again. Okay, so this is also a hydrocarbon reacting with oxygen. You get carbon dioxide and water. Let's look at the reactant and product side. We have carbons. How many? 4 carbons on the reactant side, and on the product side we have only 1 carbon. So in order to get 4 carbons on the product side, we are going to put 4 over here. Now let's look at hydrogens. We have 10 hydrogens on this side. On the reactant side we have 10 hydrogens. Here we have only 2 hydrogens. So we have to get 10 also over here. So we are going to put 5 over here. In that case, we are going to have 10 hydrogens in total. Now oxygens on this side, on the reactant side, we have only 2 oxygens, as you can see. On the product side, how many oxygens are there? 4 2s are 8 and 5. That is equal to 13. So we have again an odd number, and in order to balance that, we can use a fraction, and the fraction is going to be 13.5. 13 divided by 2. That will be equal to how many? that will be equal to 13 oxygens. Okay, so we have oxygens also balanced. This is another example. We have C2H5OH, which is called ethanol, reacting with oxygen. The product will again be same. What is the product? Product is again carbon dioxide and water. Always remember hydrocarbons reacting with oxygen. Straight away write carbon dioxide and water as the products. Now reactant side and the product side, we have how many carbons on the reactant side? We have 2 carbons on the reactant side, and on the product side we have 1 carbon, so we put 2 over there in order to balance carbons. The second step is going to be hydrogen. How many hydrogens are there? We have 6 hydrogens. Look over here, we have 5 hydrogens and 1 over here. So this makes 6 hydrogens on this side. So 6 in total on the reactant side and 2 in total on the product side. What I'm going to put over here to make it 6? Obviously 3. When it multiplies with 3, it becomes 6. Now oxygen. How many oxygens are there on the reactant side? We have 1 oxygen over here and 2 oxygens over here. So it makes it 3 oxygen. And on the product side, we have 2 to the 4 and 3. 7 oxygens. Okay. Now in order to make this side, we have to get 7 over here in total. I have to put some number over here with oxygen so that I can get 7 oxygens. So what is it going to be? This is going to be 3. Because once I put 3 over here, this becomes 6, and 6 plus 1, this oxygen also adds up. This makes it 7. Okay. So this equation is balanced now. Okay, let's review mole. We have learned that mole is defined as a mass of substance by molar mass of the same substance, small m divided by capital M. Small m is a mass of substance and capital M is molar mass. Okay, this is the formula of mole, and we know that the number of particles are equal to moles multiplied by Avogadro's number. So when you have moles, when you multiply that with Avogadro's number or Avogadro's constant, you get the number of particles. Let's look at a question. We have a combustion analysis question over here. What is combustion analysis? Combustion analysis process is the one in which you have a combustion equation. With the help of that, you find out the number of moles. Okay, so that is called combustion analysis. So what the question says: find number of moles of oxygen required to completely combust 2.5 moles of ethane. So we have ethane, we have combustion of ethane going on, and we have to find a number of oxygens. Okay, let's construct the equation. We can construct this equation by ourselves. We are provided with the formula of ethane. We know that oxygen is O2, ethane is C2H6 plus oxygen. What is the product? Carbon dioxide and water. To balance the equation, we are going to apply the same method: carbon, hydrogen, and then oxygen. And once we balance it, the equation looks like this. And our next step is going to be applying mole ratio. How are we going to apply mole ratio? First, we have to see what we are comparing. We are comparing oxygen to ethane. So we write oxygen and ethane separately over here, opposite to each other. How many moles are there of oxygen in the equation? We have 7.5. Okay, so we write 7.5 mole over here for oxygen. How many ethane moles are there? We have only 1 ethane mole. Okay, 1 mole of ethane. And oxygen's moles are required, so we write X for that. We have to find out the moles of oxygen, so that is X. And how many ethane moles are there? We have 2.5 moles of ethane provided in our question, so we put 2.5 over here. Okay, the first thing, this thing is going to be from the equation, and the second thing is going to be from your question. Okay, remember. Now we cross multiply these ratios. Once we cross multiply, the 7.5 multiplies with 2.5. As we know, 7.5 is equal to 3.5. We can write 3.5 for the calculation purpose. So 3.5, this 2.5 multiplies with 3.5. We get 3.5 into 2.5 over here, and we get 1 into X. And when you find out the value of X, you get 8.5. So how many moles of oxygen are required? We have to have 8.5 moles of oxygen in order to combust 2.5 moles of ethane. Let's look at question number 2. We have to find out mass of oxygen required to completely combust 35 grams of ethane. Now this question relates to mass, not moles. Okay, so this question is related to mass. Whenever you have mass, you have to apply the same mole ratio but including masses as well. Let's look how we are going to do that. First, construct the balanced chemical equation. Once we balance the same equation we are using for ethane, so it's going to be the same. Now on one side, as a rough work, we have to find out the molar mass of C2H6. The molar mass of C2H6 will be 2 carbons plus 6 hydrogens. That is equal to 30 grams. Okay. Then apply mole ratio. How are we going to apply mole ratio? We are comparing oxygen to methane. So we write oxygen adjacent to ethane. And then we have how many moles of oxygen from the equation? We have 7.5, that is equal to 3.5 moles. Okay. We have moles of oxygen multiplied by the molar mass of oxygen. So whenever you're dealing with masses, you always apply mole ratio in this method. We have the moles from the equation, which is 7.5, which is equal to 3.5 moles, multiplied with 32 grams. 32 grams is the mass of oxygen, O2 ka mass. Okay. And on the other side, we have the moles of ethane from the equation. We have only 1 mole of ethane over here, and multiplied by the molar mass, which is equal to 30 grams. Okay, so we have 30 grams over here because of that. Now we have to find out the moles of, or the mass of oxygen, and we are provided with the mass of ethane. How much mass is given? 35 grams. So first thing is from the equation as usual, and second thing is from the question. Now we simplify by cross multiplying these values. 3.5 multiplies with 32 multiplies with 35. Okay, that is the same. 3.5 multiplied by 32 multiplied by 35. On the other hand, 1 multiplied by 30 multiplied by this x over here comes on the opposite side, so it is 1 into 30 into x. So simply we cross multiply all the values and we sum it. We find the products. This is 3920 is equal to 30x. Okay, when we have to find out the value of x, we shift this 30 on the opposite side, so it divides 3920, and we have 130.66 grams, which is the value of x. What is that? This is the mass of oxygen. Okay, we have found out the mass of oxygen. So how much oxygen is required? We have to have 130.66 grams of oxygen to completely combust the given 35 grams of oxygen, ethane. Okay, in the third example, we have to determine the amount of carbon dioxide produced when 16.5 grams of ethane react with oxygen. Now we have to compare two things over here. We have to find out the ratios of carbon dioxide to ethane, not oxygen. Okay, so this time we are going to compare carbon dioxide and ethane. First thing is going to be the same. We have to construct the equation, as you know how to construct the equation. Then we balance it. Once we balance it, we get the exact amount of moles from the equation. On one side, we are going to find out the molar masses. As usual, we know that the molar mass of ethane is 30 grams. Now we apply the mole ratio. We compare carbon dioxide to ethane, because this time we are comparing carbon dioxide and ethane to each other. How many moles of carbon dioxide are there from the equation? We have 2 moles of carbon dioxide, so we write 2 moles multiplied by molar mass of carbon dioxide, because we are dealing with masses now. 44 is the molar mass of CO2. And on the other side, we have ethane, which is equal to 1 mole. From the equation, we have 1 mole and 30 grams is the molar mass. So same thing we are applying over here as well. And in the second step, we have to find out carbon dioxide. So we call it X. And how much mass is given? We are given with 16.5 grams of ethane. Always remember one strategy. On first we write the things given from the equation, and the second step is going to be from the question. Now we cross multiply all the values in the same manner that we did, and we find out the value of x. The value of x in this case is 48.4 grams, and we know that 16.5 grams of ethane, which is given, is going to produce how much carbon dioxide? It produces 48.4 grams of carbon dioxide. So students, this is your task. We have to find out the mass of oxygen required to completely combust the following. We have 2 grams of propane, we have 15.5 grams of methanol, and we have 13 grams of butane. So these are three questions, okay? And you have to find out the mass of oxygen in each case. And for that, the hint is you have to first construct the chemical equation using propane. The example I'm giving you is of propane. For example, you take propane, you add it to oxygen, and you get carbon dioxide and water. In the same manner, you're going to find out the masses of oxygen in all these three cases. Okay, so I hope the lesson was understandable. Meet you in the next lesson.